Peek out that window and show me their positions! Answer! God damn it! These savages! How am I gonna look at the positions now?
So, mirrors are composed of many elements. Modern mirrors in particular are made of way more elements to improve durability, quality, and image clarity. But for the sake of simplicity, we'll just be covering the standard process and materials which are used to manufacture most modern mirrors. The glass uses silica sand, or SiO2, as its primary structural ingredient. Soda ash may be added to lower the glass's melting point. Limestone and dolomite are also added to improve mirror stability and durability. Cullet or recycled glass may also be added to reduce energy consumption and the raw materials needed. Other minor ingredients such as iron oxide may be added to control the melting point, the refining, and the color. For example, iron oxide provides a green tint. Float glass is typically used for modern mirrors because of its smooth, distortion-free surface, which the reflective silver or other metal layer can be placed on.
The compound most commonly used for providing the mirror with its reflective surface is silver nitrate, or AgNO3. This is the source of the silver. Reducing agents are used to convert the silver ions into silver metal. Some common reducing agents may be formaldehyde, glucose, or invert sugar.
Finally. Hey, did you know that ammonia solution, specifically NH3, is used to form Toland's reagent, also known as ammonical silver nitrate, by dissolving silver oxide precipitate?
Sodium hydroxide, NOH, or potassium hydroxide, KOH, is used to adjust the alkalinity of the solution. Distilled water, or H2O as we all know, is essential for washing and ensuring the mirror's quality isn't affected by contamination. No one wants that. Modern mirrors also require durability to prevent tarnishing or oxidization of the silver. Tin 2 chloride, or SnCl2, is used as a sensitizing agent applied to the glass before silvering to improve the adhesion of the silver to the glass's surface. A layer of copper is then often added or applied over the silver to further improve corrosion resistance. Backing paint may also often be added as a lead-free alternative to this coppering. They usually contain lead-free pigments in modern mirrors, so no one gets lead poisoning.
The silvering process is one of the most important steps in mirror manufacturing, as this is what gives the mirror its reflective surface. In modern mirror manufacturing, the most common method used is chemical or wet deposition. This is the standard method for most household furniture and decorative mirrors. It uses a wet chemical reaction, giving its name, and other methods like vacuum deposition and magnetron sputtering are also used, but those methods are typically used for precision high reflectivity mirrors, such as telescope mirrors, and for depositing aluminum or specialized, very durable and high quality mirrors. In this process, the glass is cleaned with tin chloride, a sensitizer, and then a silver nitrate solution is sprayed onto the surface, giving it a silver metallic layer. Many of the reducing agents which were mentioned before are used in this method. Chemicals used in this process to reduce silver ions to metallic silver include invert sugar, Rochelle, or formaldehyde, and also I forgot to mention salt. To prevent the silver from oxidizing, a layer of copper is often added, followed by protective anti-corrosion paint. So the question is, why do mirrors have its properties. Now first, silver is the top choice for mirrors because it reflects 100%, well nearly 100% of light, and making it the most reflective material across the spectrum. At a chemical level, silver atoms have free electrons that are not tied to any single atom and can move easily in a sea of light. When light hits the silver, these mobile electrons oscillate in perfect sync with the light wave and immediately throw energy back up, which you see in the reflection. Bright reflection in front of the mirror. Because silver reflects all color of light almost equally, the image it produces is clear, very clear, and has very little, almost none of color distortion compared to other metals, right? And other metals like gold absorb certain colors. That's why when you look at a very shiny piece of gold, it's not as, realistic, or it doesn't really have the same image that the mirrors produce. So gold absorbs blue light, for instance, which is why it looks so yellow. But silver's unique atom structure prevents it from absorbing much visible light at all. And this chemical efficiency is why silver remains the king and the standard for creating mirrors.
Now, let's take something like the periscope. The way it works is that there are two plane mirrors, or flat mirrors, facing 45-degree angles facing each other, reflecting light upon each other to bring light into the viewer's eye. The periscope here is especially used as a highlight to how mirrors can be used in day-to-day usage, especially in the military and the Navy. It's been used in war and, right now, even in submarines. The periscope was first found by Johannes Gutenberg in 1430 in a field, but more than 400 years later was the term periscope formally coined by French inventor Hippolyte Marie Davy. The design followed the standard 45-degree mirror in a tube structure that the traditional periscope followed. The design was used by soldiers to look over trenches without getting their head shot, and also for submarines to view outside the waters. But this was also upgraded with the implementation of lenses, so you can also view over waters with different magnifications. All in all, mirrors are one of the greatest inventions of humankind and will continue to serve its purpose in day-to-day uses.
I got you now. God damn.